Today's summary, we have EWIS history, the applicable CFRs, general practices, wiring practices documentation, wiring selection, connective devices and connective devices repair, wiring inspection, and housekeeping. We're going to focus mainly on the inspections and housekeeping, some basic history, the rules, and some general practices. We've got some objectives for today's training. First of all, you will need to be able to state at least one precaution regarding EWIS maintenance, state one precaution regarding EWIS inspection, and state one precaution regarding EWIS repair. Now before we get started, please make sure that you have printed out your test and you have your test there in front of you. If you haven't gotten your test printed out yet, stop this video and go ahead and print it out so you can have it while we go through the presentation together. So let's talk a little bit about the introduction. In the 1980s, things were pretty bad in the aircraft industry regarding the wiring. There were a lot of problems and a lot of accidents that were traced back to faulty wiring systems. So that's why this job aid was created, so that we can help mechanics understand how to fix these problems and also give the operators a chance to make sure everything is good to go in their program as well. So what does EWIS stand for? Electrical Wiring Interconnection System. EWIS is any wiring device or combination, including termination devices, installed in the aircraft. The purpose of EWIS is to transmit electrical energy from point A to point B. However, EWIS is not electrical equipment or avionics. It's not the portable electrical devices, and it's not fiber optics. So basically it's just the wiring system itself and the terminations. Now, in order to talk about the wiring system, we always have to link back to the fuel system limitations and the CDCCL. The CDCCL is the Critical Design Configuration Control List. The Configuration Control List tells the operator all the things about the aircraft that's going to protect the aircraft from having any kind of ignition event within the fuel tanks. So the CDCCL, the purpose is to provide instructions to ensure that the critical features are present throughout the life of the aircraft. The critical features are things like bonding resistance and separation of the wires. You want to make sure that there's no opportunity for any kind of spark to be created that could potentially cause the fuel system to ignite. Now, the next few slides we're going to have some different pictures of investigations that happened with aging aircraft. There are some inspections that happened over a few different aircraft, and a lot of problems were found. For example, if you look at the picture here, you can notice a lot of issues. First of all, look at where the wires are sitting. They're bundled, which is pretty good. Some of them are a little bit stray, but they're sitting right on top of that structure. So we have a problem here with the structure. And then notice all this garbage and what they call swarf all around the area. This could cause potential breaking in the wire insulation as well. Okay, so the first thing that people notice is the routing and chafing. Wires need to be routed in such a way that they prevent any kind of chafing opportunity. For example, you see here, there's chafing against the structure as well as over here. In addition, you don't want there to be any dirt or lint on your wires. This will prevent you from having a good inspection, and also it could cause contamination, which might cause the wire circuit to not function properly. So please make sure that you clean as you go, and it gets really nasty in certain areas, so please be mindful to clean up. Here we see an example of coil and stow problems. Take a look at this picture right here. What are some problems that you see with this wire? Well, you probably noticed first of all that these wires are squirreling about. We don't want to have any issues with wires just hanging out, the ones that are unused. You also notice that this copper is exposed, so it should be capped. And then finally, you want to make sure that everything is bundled together. Here's an example of bend radius problems. Notice how big this wire is, and then how small the bend radius is. It's basically folded in half. You want to prevent this type of bend because it could cause breakage right here. And another problem is arcing. In this situation, notice here this airworthiness certificate. This airworthiness certificate was actually moved to this present location, and the mechanics installed the airworthiness certificate by screwing it into the bulkhead. Unfortunately, they didn't look behind the bulkhead, where there were a few different wires, and these power feeder wires were drilled into, and then there was some arcing. So, sad day for those guys. Another sad day, but praise God nothing bad happened. You notice here that there were wires that were chafing, and they started to arc, and it heated up enough so that it caused a hole in the conduit. Well, what was right below this conduit? Nothing but a fuel line. And you notice here that there was a lot of heat that caused the discoloration in the fuel line, and thank goodness that it didn't heat up enough to cause some sort of ignition event. Another crappy day for these guys. Here we have a lavatory, and the lavatory was leaking. Unfortunately, there were no drip pans beneath the lavatory to protect all the wiring components underneath. So the lavatory dripped, and it dripped onto some connectors, and that connector situation arced, and we caused this problem here. So based on these inspections, it was obvious that the previous regulations were inadequate. There was not enough protection of the wiring system, and things were starting to break. So now the FAA has beefed up its certification and operational regulations. The FAA realized that the wiring system is crucial to safety, so they have this safety initiative that treats the wiring as a system. It mandates and integrates the operator's support with the manufacturer. The goal of this rule and initiative was to enhance safety by improving all aspects of the electrical wiring systems, in that there was harmonization between the mechanics and operators, the manufacturers, and the FAA. A key point to remember here is that the wire and the associated components are now treated as an entire system within the aircraft. So let's talk about the degradation of EWIS. What are some things that could cause the wires to start to break down? Well, here in Hawaii, the environment is a major role in causing degradation. We have a salty, warm, humid environment. Maintenance practices, installation problems, the physical properties of the wires, and of course age all contribute to the degradation of the wires. More specific factors we'll look at is vibration. An aircraft is constantly vibrating throughout its operation. In addition, we have a lot of moisture. Here in Hawaii, again, it's a humid environment, and along with temperature changes that causes condensation, the wires are subject to a lot of moisture damage. Maintenance can cause wires to inadvertently be broken or snipped. There could be indirect damage from other systems, for example, having fluids leaking on top of the wiring system. There could be chemical contamination from things like battery acid, and heat, along with improper installation, can all cause the wiring system to degrade and not function properly. Now, as with anything in the government, there are of course a ton of rules and laws regulating the electrical wiring system. So we'll take a look at a few of them. First of all, Part 25 focuses on certification. This is a guidance to the manufacturers in helping the manufacturers create proper electrical wiring systems. It also helps the manufacturers develop maintenance and inspection instructions. It's up to the manufacturer to make sure that they tell the operators the instructions on how to operate and maintain the electrical wiring system, and they use different procedures like the enhanced zonal analysis procedure to help operators improve their maintenance practices. This policy deals with installing wiring systems, and doing that, it should not be left to the discretion of the installer. As mechanics, you guys are all very capable to install wires into the aircraft. However, it shouldn't be your responsibility to create the wiring system and route it according to what you think is best. That decision should be left up to the manufacturer and not the installer. This advisory circular gives information regarding galleys and passenger entertainment systems. These things are not necessary for an aircraft to function, but it gives guidance on how to install these components. This next AC talks about the electrical fault and fire prevention and protection to provide acceptable means to address electrically caused faults, overheating, smoking, and fire. Part 26 talks about safety improvements, and it supports the operators to be able to comply with the operational rule requirements. Part 26 mainly deals with instructions for continued airworthiness and distribution of information to the affected operators. Part 26 specifically applies to transport category aircraft. AC 43 is a popular advisory circular providing acceptable methods, techniques, and practices for aircraft inspection and repair. As mechanics, we're familiar with this advisory circular. However, this advisory circular is not the approved method according to the FAA, so you cannot sign off any maintenance in accordance with the AC 43. It needs to be signed off in accordance with the AMM. If any equipment is added to the aircraft, there needs to be a load analysis. Now typically when we add aircraft components to our aircraft, they come with an STC that has already done the load analysis for us. Let's highlight a little bit more about circuit breakers. Circuit breakers need to be the appropriate size. If they're too big, they will not cause enough protection for the wire. When there's high current, the circuit breaker will not pop when it's supposed to. So a circuit breaker has to always open before any component downstream can overheat and generate smoke or fire. The circuit breakers are designed to protect the wire, not necessarily the components, but they should be able to protect the wire from overheating and causing damage. Circuit breakers should not be used as a switch. Repeatedly opening and closing the contacts can cause damage to the circuit breaker, and then when we need the circuit breaker to function, later on it won't. Most circuit breaker failures are latent. That means that we don't know that they're broken until later, when it's really important. So please do not use circuit breakers repeatedly as a switch. They're not. Wires should be sized so that they have sufficient mechanical strength. Now, it's probably not going to be up to you to decide what size wire to install. The IPC should designate when you have to make a repair what specific wire to use. But make sure that you are following the directions of the IPC and the AMM. It might be necessary to replace the wire or substitute the wire, but the manufacturer has to give permission and approve any substitution. Another thing to consider is EWIS routing. Wires should be routed throughout the aircraft so that we can eliminate the potential that they have for chafing against other structures or components. They should also be eliminated from potentially being used as a handhold or a support. They should not be exposed to damage from maintenance crew or shifting cargo, and also from exposure to battery electrolytes or other corrosive fluids. For example, you can see here this is from a Pratt & Whitney best practices. Looking at the routing here, you notice that the installer routed the wires so that there's chafing all across the engine. This is somebody with experience routing these wires, and notice how poorly things have been routed. So please be mindful that when you put engines back together and you're doing your engine changes, that the wires are routed appropriately. Here are some pictures of EWIS riding on structures. That's improper. Make sure that they're lifted away from the structure here. When EWIS cross over each other, they need to be tightly secured with each other. In this situation, if there's any vibration, the wires are going to flap back and forth onto each other and cause chafing. When they're tied together, they'll move together as one unit and thus avoid any kind of chafing. Look at this picture. You have the wires routed through a lightning hole, and they're sitting here on the structure, and they're not even on the grommet. The grommet doesn't have enough space around it to cover the entire hole. So you've got to make sure that first of all your grommets are the proper size and that the wires are not touching anything. So this picture is much better. It sort of reminds me of that game Operation that I'm really bad at. You don't want the wires to touch any of the sides. This is naughty. You should not be grabbing the wires as a handhold. Wires can be in wheel well and other exposed areas, especially during gear swing. You want to make sure that those wires are not pinched or in a place where they could sustain damage. It's common sense to route the wires above fluid lines, because what happens if the fluid drips? If the wires are below the fluid lines, guess what gets damaged? This last point talks about slack. You want to make sure that you have enough slack in the wires to prevent mechanical strain. If the wires are too tight, then they could cause damage. In this picture, you'll notice that the wires are clamped, and they're probably clamped in this picture about 24 inches apart. But if there were any type of break, the wire could potentially be touching this metallic fluid line. So we want to make sure that we have zip ties in between so that if there is any break, when the wire swings down, it's not touching anything below it. Take a look at this picture and use your inspection glasses. What's wrong with this picture? Well, first of all, you probably noticed some chafing. Here along the hydraulic line, the wire is touching the hydraulic line. In addition, you probably noticed that this is nasty. There's a lot of hydraulic fluid on here that should not be exposed to electricity. And also you might have noticed that these wires aren't bundled tightly together. They're just free flowing about. So the wires need to be bundled, the area needs to be cleaned, and there should not be any contact from the wires to the hydraulic lines. In this picture, I just want to emphasize that the heads of the zip ties should not be in a place where they could cause stress or puncture the wires. So as you notice here, all the zip tie heads are away from where they could cause any friction. Same thing over here. Your zip tie head should not be in this area where there could be chafing. Here it's free and open in the middle. This picture emphasizes that there should be sufficient slack when wires are routed from the terminals into their bundles. These should not be super tight. You want to give them enough slack so that there's not strain. A standoff is a component, a small little component that is used to maintain clearance between the wires and the structure. Here's an example of a standoff, and this right here, it's basically a clamp that allows the wires to stand off away from the structure. This person who installed this standoff must have been a new mechanic because he didn't realize that he installed it the wrong way. If you look at this picture, you'll notice that the wires are now indeed standing off away from the structure. Again, we don't want any bundles riding on the structure. For clamps, we want to make sure that they're not more than 24 inches apart. In addition, the clamps need to be the right size. If the clamps are too big, then the wires aren't going to be properly supported. If the clamps are too small, the wires could be crushed. When you're mounting the clamps, this third point talks about mounting the clamps with the attachment hardware on top. And this last point says that tying is not an alternative to clamping. Here we have our clamps 24 inches apart and there's sufficient slack. Make sure that there's sufficient slack, that the wires aren't tightly strapped together. In addition, we need to make sure that our clamps are properly positioned. Notice here that the rubber is distorted. We do not want there to be any distortion of the clamps. You'll have to reinstall that clamp properly. Another thing to be mindful about with installing clamps is their orientation. You want there to be a straight T as they cross each other. Here we notice that this T is not quite straight. It's got a wobble. Down here, it's pretty obvious that this clamp is not installed straight, and now what we have is a problem with potential pressure and chafing happening here and here. Here's a picture of clamps being distorted. So make sure you keep an eye out for distorted clamps with smushed rubber as you make your inspections. I've not seen this on the aircraft, maybe you have, but if there are any plastic snap-in clamps, these should not be in high vibration or high heat areas. These are sort of like clamp zip ties, so if there's any kind of vibration, they could come loose. Rubber clamps sometimes have a wedge over here, so you need to make sure that there's no pinching as the wires pass through. They also need to be installed properly, so if there's a slot here, make sure that everything is in its proper place. Again, we don't want the wires to be pinched underneath the clamp. So here's a picture of a careless installation. You notice here that somebody pinched the wires as they installed the clamp. Now, wouldn't it be great to have a few extra sets of hands? We could use one set of hands to close the wires together, another set of hands to close the clamp, and then another set of hands to tighten down the screws. But we don't have extra sets of hands, so you're going to have to use some mindful magic to make sure everything gets installed properly. In this case, somebody didn't even screw the clamp in together. It's missing some hardware. So please make sure that all of your hardware is in good shape. Just like this one, if it's got broken rubber, please discard and get a new one. Now let's talk about bend radius. You notice up here that bend radius needs to be 10 times the outside diameter of the largest wire. That's if the group of wires is unsupported. If the bundle of wires is supported, that bend radius is minimized to 3 times the diameter of the largest wire. So here's a picture. You've got this wire that has broken out from the bundle and has returned back here to the termination. You've got right here, it's tied, but over here, is there any support? No. So, what's the minimum bend radius for an unsupported wire? 10. Let's look down here. We have a support here and a support here. It doesn't need to be 10, now the bend radius only needs to be 3 times the diameter. And over here we have some ties here, so that's supported, and a tie here. So again, what's the diameter of this bend radius? 3 times. Okay, so this looks like it's okay. It might just barely be enough. So here let's look at our blue wire. Here's your outside diameter. I'm going to just eyeball this one and say we've got 1, 2, 3, maybe 3.5 the outside diameter for this bend radius. So it looks like that's okay. It's not crushed too much. But now look at this one. It's basically folded in half, just like we saw earlier. So please be careful about the bend radius. We talked about unused wires as well. They need to be secured. They need to be individually cut with the strands, even with the insulation. The copper should not be exposed. And then they should also be insulated and closed. So, in some cases you can use sleeving and tie it back to the outside of the wire. And then make sure that the wire is bundled in with the rest. In this case, you can also use a protective cap and then tie the wires all back in with the rest of their bundle. So notice this picture. This wire here is breaking all 3 of the rules. First of all, the copper. Is it exposed beyond the insulation? Yes. Now, is there a cap on top of this wire, or is it free and open? Obviously, there's no cap. And finally, is this wire bundle secured with the rest of its friends here in the bundle? No. These strands are left open and free, so all 3 rules are broken. Naughty. In some cases, we have longer wires than there is space, so there will be coil and stow methods. If the area is a low vibration area, you can just coil and stow the wires like this with a little bit of the bundle ties. You can also stow it this way. But if it's a high vibration area, notice how many more tie-offs there are to make sure that there is no chafing during the vibration. So this is really obvious. If you notice during your inspection that wires are chafed or frayed, or the insulation is suspected of being penetrated, it's time to change out that wire. Also, if the insulation is cracked or damaged or overheating, you have to replace the wire as well. Here's an example of overheating. It's usually discolored. And in that case, we don't know what happened to the wire and there's probably internal damage. Other reasons to replace wires is if they're crushed or kinked, if there's shielding corrosion, if the wire shows that there are cracks, dirt, or moisture that have gotten into the sleeving, or if the wire splices are less than 10-foot intervals apart. Shielding is important because it protects against electromagnetic interference. So replacement wires need to have the same shielding characteristics as the original, and the replacements need to be installed inside the bundle shield. So when you do replace wires, you need to make sure to add them in with the rest of the bundle. They cannot be hanging out outside of the pack. Again, you see wires just hanging out. They need to be bound together with the rest of the other wires in the bundle. Now, we talked a little bit before about wire splicing. We need to keep the wire splices to a minimum. It's said before 10 feet intervals. Now, it's important to avoid splicing in high vibration areas because that constant vibration back and forth can cause the wires to come loose within the splices. They should be located in places to permit inspection. If you can't see the wire splice and inspect it, then we have a problem because it could be damaged. It's important to stagger the wire splices so that the bundles themselves do not have big bulges in them. So here we have an example of staggered splices. Everything is nice and even. Splices can be overheated. If there's damage and they start to break free, then we can have a potential arcing problem here. So be on the lookout for these overheating splices. Now here's an example of a bundle that looks like it has a tumor. All these splices are in the same place, so now the wire is bulging and it could cause potential installation problems. In this case, we have splices that were made with wires that are too short. Now we have mechanical strain. Now it's important to make sure that splices are done properly and in an airworthy method. For example, this looks like somebody used electrical tape around the splice. I don't think electrical tape is allowed. Now we'll move on to talking about terminal ends. The end of the wire, or the terminal, should be just as strong as the wire itself. So if somebody pulled on the terminal, it should not be weaker than the rest of the wire. Terminals are metal, so they shouldn't be bent back and forth. It will cause them to break. Terminal strips function as sort of like a junction box. So these are places where wires come together to transfer electricity. The studs in the terminal strips should not be contacting each other, and the current should not be transferred on the stud. It should be transferred with the terminal contact on the surface. The studs themselves should be anchored against rotation. They should not be able to spin. And if there are any defective studs on a terminal strip, be sure to replace them. It's important that metallic objects and other debris cannot fall on top of the terminal strips. So if you do have to mount a strip somewhere on the aircraft, make sure that it's in a place where gravity is not working against you. In some cases, where terminals attach to a certain point, there needs to be a torque. So in this case, you'll notice that there's torque seal to show the mechanic right away if there has been any rotation with the terminal. Notice here, these power feeder terminals also are guarded against rotation and use the torque seal to indicate any rotation. They're also protected from each other with these bridges. There shouldn't be any contact here with the power feeder terminals. And notice they also are shielded, so there shouldn't be any corrosion here on the shield. Terminal lugs. It's important not to overload the studs. You can only have 4 lugs per stud, so make sure that you're not adding any extra terminal ends to each stud. And also, the studs diameter and the terminal end diameter need to be pretty close together. You shouldn't have a really big terminal end with a very small stud. That will not transfer the electricity appropriately. As you stack the terminals on top of each other, there needs to be a flat washer, a lock washer, and then a nut. And everything should be stacked so that there's no space in between any of these pieces. Sometimes these crimp barrels make the stacking a little bit challenging, so in some cases you'll need to make sure that the fat end are away from each other and the skinny end is closer to each other. In some cases you might just have to make them V off instead of being straight on top of each other. So it's a little bit blurry to see this picture, but here we have a space between the nut and the rest of the washers. This is bad and it could cause arcing here. You want to make sure that the lock washers are fully compressed on with the terminals. In some cases, if your washer is a little oversized, it can cause a gap. So make sure that your washers are all the correct size when you're stacking them together. Okay, Put on your inspection glasses and try to find the mistake that was made here during the installation. Do you notice over here, it's kind of a clue that the torque seal is all smushed over here. It looks like something's missing. Do you have any extra parts in your parts tray? Somebody's got a lock washer hiding. Maybe it fell on the floor and they didn't realize it. Grounding. It's just as important on the ground side as it is on the power side. A lot of the electrical problems are because the ground is bad. So make sure that there's no corrosion and that the grounds are nice and tight. It's important not to mix up power grounds. For example, if you have AC current, that should not be grounded in the same terminal or area where a DC current is returning. That could cause a lot of noise and problems with the components. All components need to be externally grounded. Even if they have an internal ground, all the components also need to be connected externally to the airframe. Especially if there's heavy current grounds, there needs to be proper metal-to-metal bond. You don't want there to be any kind of impedance between the grounds. When components are properly grounded, that will reduce the possibility for electromagnetic interference. It's important to make sure that each wire is properly identified. That's necessary for safety of operation, safety to maintenance personnel, and ease of management. You don't want to have contact with the wrong wire and potentially expose yourself to injury. When you replace wires, it's important to make sure that you have properly identified the wire. You can check on the wiring diagram to make sure that the wire is identified properly. If you're replacing a wire that's less than 3 inches long, you don't need to have a specific marking for the wire. I'm sure it would be helpful, but anyone looking at the wiring diagram should be able to tell what wire that is. So here somebody replaced this wire, and he did a good job of including the marking here to make sure everyone knows what specific wire this is. We'll move on now to connectors. There are 3 main types of connectors. Of course there are many, but they're generally circular, rectangular, or module blocks. They can be pretty simple or really complex, so it's very important to maintain proper connector care. One thing to remember about connectors is to make sure that they're safety wired properly. Connectors can be really fragile, so people who are safety wiring should not yank really hard as they're doing their safety wiring. You're not going to be able to gauge your own strength, and it's really easy to yank this hole right out. When you safety wiring things above your head, sometimes it can get a little confusing. Here, notice this is improperly installed safety wire. If you pull on this safety wire, is it going to pull the component looser or tighter? In this case, you're going to be pulling it looser. To make sure that you switch around the safety wire so that instead it's pulling the connector tighter. Rectangular connectors can be pretty complex as well. When you're installing line replacement units, make sure that you've got really good contact. Sometimes components can even click in place, but make sure that those connectors are properly installed. In some cases, we have module blocks like these terminals. Again, make sure that there's proper connection and that they're installed properly and seated correctly. Sometimes terminal blocks, when they're installed, the technician might install them with not enough slack. There should not be any tugging of the wire. The wire should be nice and loose outside of the terminal block. Here we have another problem with slack. Notice here that those wires are being tugged. In the second picture, now everything is nice and slacked. With connectors, we have to be mindful of our connector care. Pratt & Whitney gives some directions on how to install connectors with the covering on top. So in the engine, there are a lot of things that can contaminate the connectors, and they found that the aircraft responds more reliably when the connectors are wrapped. So you'll wrap the connector with tape or heat shrink. It's an extra step, but it goes a long way in aircraft reliability. Sometimes wires need to be routed through conduits. Conduits provide physical protection of the wire so that they are not damaged due to some sort of outside force. The thing about conduits is they can accumulate moisture inside, so you want to make sure that there are drain holes, and you also want to make sure that there are proper clamping. When you see a conduit, you might think, hey, this is metal, I can grab onto it. But that's not the case. The conduits are also fragile, so make sure that you put the conduits in places where people aren't going to naturally want to grab them and use them as a handhold or a step. When you do install conduits with drain holes, make sure that you remove those burrs. The burrs could also cause damage to the wires inside. At the end of the conduit, notice here that the covering is broken, so that will cause exposure inside the conduit to moisture and other contaminants. If you notice that, just replace the covering. Real easy. Circuit breaker resets. Now we talked about circuit breakers a few slides ago, but it's important to remember not to reset circuit breakers. I think you're allowed one circuit breaker reset, but if the problem persists, you've got to stop and inspect what's going on. In this case, notice here there was a severe arcing event. This was caused because the circuit breaker kept getting reset and reset and reset. Finally, the wires couldn't handle the amount of current that was flowing through them, and they broke. EWIS separation means that the wires are separate from other systems that could cause problems. For example, in some cases there could be electromagnetic interference, so certain wires need to be separate from each other. And also, electrical systems should be away from fuel systems, because what happens with electricity and gas? Hydraulic systems are also dangerous. Oxygen and sparks don't mix either, and neither does electricity and water. So you have to make sure that the wiring system and the other systems are adequately separated. Now what we've been talking about is we've been pointing out a lot of things for you guys to look for as you're inspecting, and then things to be mindful of as you're doing your maintenance and repair. So when you're doing your inspecting, most of the time it will call for what's called an EZAP, an Enhanced Zonal Analysis Procedure. It basically breaks the plane down into zones, and within each zone you're going to do an inspection. There are 3 different types of EWIS inspections: the general visual inspection, the standalone, and the detailed inspection. A general visual inspection is just that. It's simple, it's general. You're looking at a distance, probably an arm's length away, for things that could be obvious problems. A standalone general visual inspection is when you need to do that general inspection, but it's not planned, it's coming up because of a certain circumstance. Maybe there's been some reliability issues and you have to do an inspection because of that problem. And then finally, there's a detailed inspection. That's an intense examination of the item. It's as if you made a shaka and put your shaka on your nose, and that's going to be the distance you are away from the system. So you're going to clean it, you're going to look at it with your mirror, you're going to use a light, and really make sure to inspect for any of those problems. We talked all about the different things to focus on during your inspection. We talked about clamping points. We talked about connectors. We talked about terminations. We talked about back shells. That's in the connector, the strain and things of the wires going into and out of the connector. We talked about damaged sleeves and conduits and grounding points. So, where on the aircraft do we need to pay extra special attention? In the wings, when the flaps operate, wires can be exposed. In the engines, you've got a lot of things going on there. It's really hot, there's a lot of vibration, and there are a lot of chemicals all around the engine. In addition, the engines are usually a high maintenance area, so people could inadvertently damage the wires as they're doing other maintenance. We talked about the landing gear and the wheel wells. That's a nasty place. There's a lot of environmental issues. It's dirty, it's gross, there's a lot of vibration, there's a lot of movement as the gears extend and retract, and there's a lot of chemical contamination there too. Electrical panels, there's a high density area. That's where a lot of maintenance is, and a lot of things are smushed into a small place. So this is a place where wires can be damaged easily. Line replaceable units, those are constantly being removed and installed on the aircraft. So with all that removing and installing, it also provides potential for damage. Batteries, there's chemical contamination and corrosion around those. And then power feeders. There's a lot of electrical energy going through there, so it could heat up really hot, and it's very important to make sure that those areas aren't damaged. Galleys and lavs. Those places are nasty. There's a lot of water, there's a lot of contamination, so you've got to make sure that the wires are protected there. In the cargo bay and the underfloor area, there's a lot of maintenance activity going on. Surfaces where wires can be moved and bent, and then access panels, there could be other maintenance activity causing damage there. So, when EWIS components are installed, you can't use stuff from Home Depot. It's important to use aircraft quality, aircraft grade equipment. I do think there is one vendor, Grainger, that's on our accepted vendor list, but other than that, last time I checked, Home Depot was not on that list. So we need to make sure all of our components are qualified. We talked about this before, but I just want to emphasize making sure that your grommets are fully covering the entire lightning hole and that your wires are going through without touching the sides. We talked about this before too. FOD. You've got swarf or metal shavings here that could cause potential damage to the wires. Tie wrap ends. You want to make sure that these are cut short. So this should not be just hanging out there. Snip it short. I don't really like how this person did that either. This looks like a potential stitches opportunity. So make sure that you're using your flush cutters to cut the zip tie flush to the head. Sometimes the sleeving can be gapping and expose the wires inside, so make sure that you install your sleeving properly. Now when you look at your wiring diagram, you want to make sure that you understand what the diagram is saying. It tells you a lot about the wire selection, the different kinds of connectors, and what wires are going into the connectors, and grounding points. You can check out the wiring diagram on your Bombardier Navigator or online at iflybombardier.com. And the installation drawings should talk about clamps and routing and feed-throughs. So as a brief summary, we talked about the history of EWIS and problems in the past and how the FAA is helping to mitigate those problems for the future. We talked about the rules. We talked about general practices. We talked a little bit about documentation and the wire selection. We talked briefly about connective devices. Connective device repair is going to be a hands-on workshop that will be developed in the future. Wiring inspection, and housekeeping. And finally, let's revisit our objectives. Go ahead now and jot down one precaution regarding EWIS maintenance, another one regarding inspection, and your final one regarding repair. You can jot that down on your test and then go ahead and finish your test. When you're done with your test, you can return it to the Records Office inbox or to the Maintenance Training Manager directly. Thanks so much. And if you need to review this video, you can do so, or if you'd rather just flip through the PowerPoint slides, you can take that from the email that was sent to you along with this test. Thanks so much, guys. Have a great day.